So for this one, we're trying to decide whether 6 is a solution of this equation. Well, what that means, if it's a solution of the equation, that means it makes this a true statement. Okay, so we're going to plug 6 in. 6 plus 2 equals 8. Yes, it does make it a true statement. So it is a solution, so yes. Okay? And here in this one, if we plug in 12 for the x, we get 12. I am going to need a new pen. Over 3 equals 5. Well, that means 4 equals 5, so that's a no. That's not a true solution or a true statement. So go ahead and do the U try. Was this true or not? Yes, so it's true. So 17 plus -2 equals 15. Yes, that's true. So that's a solution. Okay. Or you can write yes, it's a solution. All right, so equivalent equations are equations that have the same solutions. Go ahead and write that in there. And finding equivalent equations is that's what we do to perform the steps of solving an equation. But we're going to even back up a little more, and we just want to see right now which equations are equivalent. So we're trying to show that these equations are equivalent. So what we can do, and what the book does, and what they want you to do in your homework, is use substitution. So if t equals 6, we can substitute that 6 for the t here to show that these are equivalent equations, that they really say the same thing. And we'll talk later about how we could use subtraction here. Subtract 2 from both sides, and you'd get t equals 6. And that's another way to show that they're equivalent equations. But for this purpose, and in this section of your book, they want you to use substitution. So we're going to take the 6, plug it in, and it's basically what we were doing up here. We've got 6 plus 2 equals 8. Yes, 8 equals 8. So it is an equivalent equation. I'm doing my mouse. Did you guys get a lesson? Yeah, go ahead and grab a lesson. Make sure you sign in. Okay, same thing here. We're going to substitute in the 36. So we get 36 divided by 3. Remember, a fraction bar just means divided by, equals 12. All right, so that works. 12 equals 12. So those are equivalent equations. Okay, so you try this one. You're able to show it was an equivalent equation? Okay, so you substitute in the 4. 16 plus 4 equals 20. All right. So now let's look at some properties of equality that we can use to take the steps to simplify these equations by creating equivalent equations. Okay, so first there's the addition property of equality. And if any of you ever, back in 5th grade, they used, some teachers used hands-on equations, and there was a scale and the little guys that you put on the scale. Does that ring a bell? And you could take this, if the scale's balanced and you put the same thing on both sides of the scale, it remains balanced. If you take the same thing off both sides of the scale, it remains balanced. And that's all this is. The addition property of equality says that if your two sides of the equation are balanced, then adding the same number to each side of the equation produces an equivalent equation. Okay, so in this case, we're adding 12 to both sides. And the goal here is to get the variable all by itself so that we have m equals something, right? It's going to equal 19. So what we're looking at is what can we add to both sides. And we're going to add, and again, I've structured these the same way as the problems in your book. So they're saying, what can we add to both sides? Well, we've already added our 12 over there. So the question mark is a 12. Okay, we're adding 12 to both sides. And it's going to result in, and this is familiar to you, I'm sure, the end result will be m equals 19. That's the goal. But they're not even asking, we're not even doing that yet. All we're doing is saying, what are we adding here if we're adding 12 there? Okay. Similarly here. Okay, we're adding 8. We want to add 8 to both sides to get this variable all by itself. So we're adding 8 over here. All they're asking is, what are we doing with 8 over here? What's the symbol? It's a plus sign, right? So this is almost so simple, you probably think you're doing it wrong. But all we're looking for is a plus sign here. Does that make sense? Okay. And again, I structured this just like your homework. Okay. So here, we have -5 equals c minus 2. We can add 2 to both sides. Oh, I just did your u try for you. I'll give you all the rest of the u tries. Okay, so we've added 2 on this side, which means we need to add 2 on this side. That's all. Same thing with subtraction. You can subtract the same number from each side of an equation to produce an equivalent equation. It doesn't change the balance. Okay, so here we want to subtract 12 from both sides, so that's what we're doing. The question mark is just a 12. Okay, so what do you think needs to replace that question mark there? Whatever you do to one side of the equation, you have to do to the other. So multiplying each side by the same number produces an equivalent equation. So here, the goal is to get x all by itself, so we're multiplying both sides by 6. So again, the question mark is just a multiplication sign, just a dot. Okay, so you try this one. 3, because we're multiplying both sides of the equation by 3. Do you see that? So x over 3 times 3 is the same thing as -7 times 3. And then the division property of equality just says you can divide both sides by the same thing. So that's what we're doing. We're dividing both sides by the same number. In this case, because we want just one x here, we want to divide it by -4. So we're dividing this side by -4, so what are we doing over here? What would be where the question mark is? Anybody? Well, we've got the number already, so what goes here? It's an operation. Divide, exactly. See, I think they've oversimplified this so much that it's confusing. Okay, so 21, so here we're dividing both sides by -3. So all they want to see is that you are dividing this side by -3. If you're dividing by -3 on that side, then you're dividing by -3 on this side. Okay? Okay. So inverse operations are operations, let me lower this a little bit, that undo each other. Okay? So if I have x and I subtract 3 from it, well, if I want to undo that subtraction of 3, I can add 3. Okay? So name pairs of inverse operations, addition and subtraction, undo each other, right? And what's another pair that undo each other? Yeah.
Multiplication and division.
That's right, multiplication and division. Okay? So, what we're looking for is what the inverse operation of this is. What's the inverse operation of addition? Go ahead and take a notes and sign in. So if I add 2 to A, what do I have to do to yes? Subtract, exactly. So they're looking for a subtraction minus sign. Okay, now here I've divided by 4. What's the inverse operation of divide? Yes.
Multiply.
Multiply. So they're just looking for multiply. Okay? And you try that one. What are we replacing that question mark with? Yeah.
Addition.
Addition, because it's the inverse of this operation.